Okay, today we are going to learn about the real number system. There are different types of numbers, which you may or may not have known. So we're going to start discussing the types of numbers that there are. So the first set of numbers is all whole numbers greater than 0. It's also called counting numbers. So like 1, 2, 3, 4. These are your natural numbers. These are the ones that when you're little and you're introducing numbers, you can go 1, 2. Oh, I have 3 pieces of candy. So that's your basic number system. They come naturally to you. Second set of numbers is called whole numbers. And what's funny is the only difference between whole numbers and the counting and natural numbers is that the number starts with 0. So it goes 0, 1, 2, 3, 4. It's kind of funny that they call that the whole numbers when 0 is actually nothing. But 0 is a very important number because it holds place value. 100, if written, means 100. It doesn't mean 1 and nothing, nothing. It means 1 set of 100, no sets of 10, and no sets of 1. So there is a significance to the 0. So natural numbers are counting numbers. Whole numbers are counting numbers, put the 0 in. The set of whole numbers and their opposite are called integer numbers. And those are the ones that we've been working with recently in order to do our operations. These are your negative numbers. So these are all inclusive, and you'll have a different graphic organizer tomorrow to try to help you sort them out. Numbers that can be expressed in the form a over b, where a and b are integers and b does not equal 0. So in other words, if they can be expressed as a fraction without a 0 on the bottom and without an infinite number like pi in it, it is rational numbers. All right, so all of these together plus your irrational numbers are all of your real numbers. All right, let's go to the next page. So let's kind of try to make some examples. Proper fractions. So these are types. That doesn't give you, nope, it doesn't. So let's come up with some examples of proper fractions. 1/2. Negative 1/2. 1/3. These are your regular, normal fractions. Improper fractions are those fractions when the numerator is bigger than the denominator. So 8 over 3. 14 over 9. These are the ones that are not, the top is heavy. That's what we usually say. Mixed numbers are numbers that is a whole number and a fraction. So you could put several examples there. 3 and 4/7. There's all types of numbers that you can do. They're mixed numbers. They have a whole and they have a fraction. Integers are your counting numbers like -1, -100, -25, -1/2. They're all of your negative numbers and your integers. Repeating decimals they usually come from a fraction like 1/3. So it would be when you do a math problem, when you go to divide, and you get a repeating decimal where it keeps going and keeps going and keeps going with the same number. It can be a solid number like that, 0.33333, but it could also be something like this. As you can tell that keeps repeating, okay? On the next page, you're going to get some examples where it's not repeating, but it looks like a pattern. A pattern is not a repeating decimal. Repeating means it keeps going and doing the same thing over and over again. Terminating decimals are decimals like 0.25 or 0.182. They end, okay? So those terminate. Terminate means they end. Hold on. Okay. This would be a terminating decimal is a decimal with a finite number of decimal places. Terminate means end. Terminar in español is the end. I believe, I hope. So that just means that these decimals end. They stop. And a repeating decimal is what I said earlier. It's one that repeats over and over again, and it just keeps going. So it never ends, but it repeats. I'm going to go to the next page, I hope. Okay, these are the irrational numbers. Irrational numbers are numbers that cannot be written as a fraction of two integers. The square root of a non-perfect square is non-repeating and non-terminating. This means that it doesn't have a repeat like 0.33333 or 0.1212121212. It does not repeat, and it never ends. So it just keeps going and going and going. So these non-perfect squares, they are going to be irrational. They're hard to explain. If a decimal is non-repeating and non-terminating, it is an irrational number. Examples of irrational numbers are, let's see if I can do this, the square root of 24, the square root of 5, pi, which is that 3.14, and I'm going to show you 3.14, blah, blah, blah. I don't know the numbers. That's one that, see the dots? Those dots indicate that it goes on forever. If you put pi divided by 3, yes, that's written as a fraction, but it's written as a fraction with pi. So since it has an infinite number or an irrational number in it, pi, it is an irrational fraction. Those are very unique. They have to have something like pi in it to make it happen. It also might be a problem like 0.1.0.11. Oops. 0.111, 0.1111, 0.1111. Now I'm going to put these dots. So it looks like something is repeating, like there's a pattern, but it's not repeating. It's not going 0.1.0.1.0.1.0.1. It's got a repeating pattern of 1, 2, 3. So that one is irrational because it does not repeat in a fashion that is the same over and over and over again. So we are going to go to the next page, and we are going to do some ways to think about these, okay? So we need to find out which ones are rational and irrational. On the next activity, you guys are going to be sorting them, but you need to think it through the same way. Is 8.75, that is a terminating, which means it ends, decimal. So that means it is rational. 0.4, that little bar over it means it's repeating. So since it's a repeating decimal, it is rational. This one is what I just talked about. You see how it has a pattern? Those zeros has a pattern, but it's not repeating. So it is a non-terminating or non-repeating and non-terminating number. So it is irrational. Is 15 a perfect square? No. Since it's not, it is irrational. Is 40 a perfect square? No. So it's irrational. 81 is a perfect square. 9 times 9. So it is. that is our lesson, but you're going to be doing more practice independently and using the video that I will come up with at some point to check and see if you've got them right.